Welcome to the session. Today we're going to talk about Codent. It's an open source project that's aimed at simplifying Kubernetes cluster provisioning at scale. Right. So all of us who've been in the DevOps world know what a pain it is to provision a cluster, right? You have to come up with an optimal way to do it at scale and to manage complex configurations as well. So Codent solves this problem. In this session, we're going to look at the challenges and we're going to see what difficulties are there in platform engineering and then approach Codent. And towards the end of it, we'll see Codent in action. Right. So I'm Bharath. I'm in the OSPO team at Kubernetes. I'm a senior software dev and an open source contributor. Been working in and around Kubernetes for a while now. Let's get started. So we all know how the cloud was supposed to be, right? But very quickly it got into this maze where everything became just so much complex. And even Kubernetes, which started as a very basic project, quickly grew. And although it is the ecosystem is what makes it today, the ecosystem has become so big that it's super complex even for an experienced person in this world. That's why we need a simplified, streamlined process, which we call platform engineering today. And for enterprises specifically, when you look at platform engineering, if I have to sum up, what are the key things that you look for? Developer self-service is extremely important. So having a dedicated DevOps team that's as big or even bigger than your development team is not scalable anymore. So you got to have a self-service portal. Your dev teams and your QA teams and your security teams and all the other teams can manage the infrastructure themselves, with the platform engineering being the backend. You also need operational simplicity. If you don't have that, then providing this for multiple teams across your company becomes extremely difficult. Customizations is again another important thing because, like I said, for different teams, the requirements will be different. So without changing the core model, having the option to customize is what brings this whole process about for platform engineers. And visibilities and control, again, at an administrative level, this is extremely important to manage your clusters. And then last but not least, security and compliance. Every company has got to follow it. That's a primary these days. So given all these challenges, there's a growing need for multi-cluster configurations. So for a platform engineer, you need multi-cluster configurations for multiple things, such as AM and work nodes or multi-tenancy, edge devices, IoT, and so on. Now, when you look at the market and see what are the options available for me to accomplish this, then if you don't do anything, that's always an option, right? So if you don't do anything, your infrastructure costs grows up, and before you realize you're paying like huge cloud bills, right? Then let's take it like a basic step ahead with DIY open source tools. Of course, there's been so many tools for cluster provisioning and maintenance in the open source market, but then there's always this learning curve that comes with it, and then you got to understand each tools, and you got to understand how one tool works with another, integrations and configurations and all that. And then, of course, you have the problem for extending it to your on-premises as well. Then, if I have to take it another step further, there are proprietary solutions, but the proprietary solutions obviously come with expensive licenses and they're quite limited to the options that they provide. And more often than not, 2 years, 3 years down the line, what's going to happen is that without you looking at it really hard, you are in a vendor lock-in, right? And if you have to expand to multiple clouds, and it becomes really difficult at that point. So to solve all these problems, we are presenting an enterprise-grade open source solution, right? That's cost efficient and that's customizable, and it's completely in your hands and your control, right? And it works on multiple public clouds as well as on-prem. This is where Codent comes in, right? At a very high level, we have three things: cluster management, state management, and observability. So the cluster management, what I mean by that is, how are you going to manage multiple clusters across clouds at scale? That level of cluster management is taken care by Codent. State management talks about the day-to operations when you deploy or need to deploy multiple applications across your clouds in a single click. That's your state management. And then comes observability. So when you have an working operation clusters and workloads and apps running on it, the one thing that's 100% needed in this world or any world is really observability tools. So we are baking this into the Codent ecosystem without having to rely on external resources where you have to again do configuration yourself. All this is there. So open telemetry is used, and you can just use it right from the package. So before jumping there, just one last thing about the golden paths that's often talked about in DevOps. So everybody wants to perfect this. Every company, every team is looking to move as close as possible to a golden path, although you can always argue there isn't one. But having something close to that is still a lot of success. It still saves you a lot of effort, money, right? And it gives you a repeatable process for maintenance as well as scalability. So especially when you have a choice of multiple clouds, then this becomes extremely important as well. A quick look at the Codent architecture. So at a high level, like I said, there are three components. One is the cluster management, one is the state management, and then you have the observability stack. So with the cluster management, what happens is we use upstream CAPI controllers. So since this is completely open source, the underlying technologies to make this happen is also open source. Based on the cloud, we have the CapEx controllers as well. Kappa for AWS, CapZ for Azure, CapV for VMware, and so on. We deploy the upstream CAPI controller as well as the cloud-specific controllers onto your management cluster. Along with that will be the Cosmotron controller. So K0s and Cosmotron form a core part in this entire architecture, wherein we use that for controller management. So this becomes your management cluster, wherein the KCM controllers and a bunch of other components that are related to Codent, along with the upstream components, are running on the management cluster. And right here in the management cluster, for state management, we have Sveltos controller. So Sveltos, like I said, is for managing the states and deploying applications across multiple clusters, right? Again, this is an open source project and it's integrated into Codent so that all you need to do, for example, if you want to provision or deploy Cert Manager across all your clusters, then all you need to do is include Cert Manager in the configuration file, and that's automatically deployed to all the clusters. And that is what's shown here on the right side in the child clusters. So in the child cluster, along with all the Kubernetes add-on services that you'll find, you'll also see that there's a Sveltos agent that's operating there to talk between your child cluster and the management cluster, right? So how you accomplish this entire thing is by defining something called as a cluster deployment. We'll look at this in detail when I go to the demo part, but just briefly, I want to mention that your entire cluster configuration will be controlled and monitored using this CR called as cluster deployment. And to facilitate the configuration of the clusters based on the cloud, we have multiple cluster templates. And to facilitate the applications configuration, we have service templates. So the example that I gave you earlier about Cert Manager is an example of a service template. An example, let's say you want to deploy it on AWS, that's defined as a cluster template, right? So this is the very overall architecture of Codent. So now let's go into the demo. And just before we go into the demo, I want to open the documentation and just briefly go through this. So if I look at the installation part, right? So we have a help package. Like I said, you need a management cluster. It could be Kind, or it could be running on any other infrastructure as well. For simplicity, you can try Kind to run on your laptop or any VM. And then all you got to do is do a Helm install of the KCM, right? Once you do this, a bunch of components are installed, like I said, the controllers, the Cosmotron controllers, a bunch of other KCM stuff. And then we proceed to define our cluster templates and then define the cluster deployments. So now let's jump into the terminal, wherein I already have a kind cluster, right? And if I do this, you'll see that there are all these namespaces. And if I do this, you'll see all the pods that are up and running. So it's exactly the same. Like I mentioned, there's on a live kind cluster, all the controllers and Cosmotron and other components of KCM, right? And the next thing, by the way, that's this. So kubectl -n KCM system is KE. And if I do cluster template get, here you go. You see all the different cluster templates. So these are pre-packaged templates that are available for you to try based on the clouds. So we have for AWS EKS, and then AWS, and then Azure EKS, and Azure OpenStack, and vSphere. Similarly, you have service templates, and by default, a bunch of service templates are baked into the management cluster when you install it via the Helm chart. Some of the examples are these, right? So all you got to do is specify this in the cluster deployment. So just to show you how that looks, let's take a look at Azure. These are all the files that you typically need, not all of them, but I'm going to show you one by one. You'll need a secret. All these instructions are provided in the docs, by the way. So the instructions are segregated per cloud provider, and it's slightly different for cloud provider based on how they expect the credentials to be set up and all that. So example, AWS, you have these keys. For Azure, you have something different, right? You got to create a service principal based on the subscription ID. And for OpenStack, again, it's all these variables, and similarly for vSphere as well, right? Essentially, there's a secret.yaml file, and then there's a credential file. This credential is referenced by the secret, and cluster identity is also referenced by the credential. Cluster identity is a file that is the CR of Azure cluster entity, and it references these stuff. Now, finally, let's take a look at the cluster deployment. So I've defined two cluster deployments here. One would be a basic cluster with one control plane and one worker node, right? And it uses minimum CPU, okay? And then there's another control plane, another cluster deployment, pretty much a similar configuration, but I've used a GPU-enabled cluster, right? I've applied both these things just to show you the other bit as well. For AWS, you have all these things as well, right? So with AWS, how you have to choose the instance type based on what you want. So here I've chosen an instance type, which is a GPU-enabled worker node. If you don't want a GPU-enabled worker node, it's absolutely fine. All you got to do is select something like this, T3.small, T3.medium, whatever is your requirement. And similarly for OpenStack as well. Now I want to show you the kind of objects that we work with. So since I've already ran this, here you go. So when you list the cluster deployments, you'll see something like this, right? Let's go ahead and list one of them and do a -o YAML. There you go. It's as simple as this. So this is where you mention the cluster template, and this is where you mention the credential, and this is where you mention the configuration that's specific to you. And this is completely customizable. You can look up the documentation for all the various fields that are available, and that's that. Just to show you another example, let's look at the OpenStack one. So there's an identity ref. This is specific to OpenStack Cloud. And then there's the control plane configuration, the worker configuration, and then the template, so on and so forth, right? So this is our private cloud. So some configuration that's related to that has to be provided. All right. Now that we've seen the cluster deployments, and like I mentioned, it's all CAPI objects, right? So you can see the CAPI object being created underneath, right? So you'll have the AWS cluster, Azure cluster, and OpenStack cluster. And you will also have the AWS machines and Azure machines and OpenStack machines, right? And finally, if I have to do a machines, then as you can see, it's listing all the machines that are available on the cluster. To access this cluster, it's as simple as getting the secret. So KA, like I said, is in the KCM system namespace. Let's look at all the secrets in the KCM system. There's a bunch of secrets, but what we're interested in is the secret that has kubeconfig appended to it. So for every cloud, you have a kubeconfig. And I've exported them all, I think. Let's also export this, and let's also export this. Now, if I go here and do this, now I'm in the Azure context. I do this, there you go. I have a single worker node and a single control plane node, and it's up and running, right? Similarly for AWS, all right, there you go. Not the least for OpenStack as well. All right, so you have all these nodes, right? There you go. It's as simple as that. And on the cloud, you can see that these machines are provisioned here. Similarly for Azure as well. So as you can see, this one is using the standard one, and this one is using instance type that has GPU support as well, right? So that's running the Tesla T4 NVIDIA chip. Then AWS has these. So essentially, it's as simple as this. End of the day, what you need to do is define your cluster deployment and specify the configuration, and Codent takes care of it end to end. All right. Yeah, you have the KCM repository. It's completely open source. You can go take a look. Contributions are absolutely welcome. We have a Slack channel as well. It's updated here. Yeah, that's pretty much it. Thank you. Thank you for listening. Bye-bye.